Hi, welcome to Code.io, and in this video we're going to solve a question called contains duplicate, and this is the third question in the blind 75 list. So I have created a playlist in the channel, you can go and check that out, where we are going to solve all the questions from the blind 75 list. Okay, so this is a very simple question, it's an easy question, and let me just read the question first. Given an integer array nums, return true if any value appear at least twice in the array, and return false if every element is distinct. Okay, I guess the question is pretty self-explanatory. It's easy. Now here, yeah, it's the contains duplicate question. So this is the sample array that we're going to take, 1, 2, 3, 1, and we're going to return true if your thing has a duplicate. Your array, if your array has a duplicate, you're going to return true. If it doesn't, you're going to return false. Okay, so there are multiple ways to solve this. Let me just go over this one by one. The first approach, or the brute force approach that you could think of, is iterating through this array in a nested manner. So let me just take a variable I here and a variable j here. Now what you would basically do is, you would have this I at a fixed position and you will try to move this j one by one. Okay, so you will compare 1 and 2, you will compare 1 and 3, you will compare 1 and 1, and you would have noticed that you have a duplicate one and you would return true. Okay, now you do this for you will be fixing the position of I at 1 and you will be moving this j to all the elements, and once you do that, you are going to move the value of I to the next position, and you are going to do the same for all the values of j that are to the right of I. Okay, you will always do the elements to the right of I. You will not do starting at first index, you will do with the elements at the right of I, because if you start at this one, it is just basically another iteration of this 2 1, right? 2 1 is our first case when we had I at 1. Now if we start j here, it will be again 1 2, which is just reverse of 2 1. So you would not do that, that would just be redundant. So you would just iterate through all the elements to the right of I, and again you will move the value of I and you will check. Now here it doesn't have any space to move. Now this goes on. So for this you will have a for loop, which is an I loop, and inside that you will have a for loop which is going to be your j loop, and inside that you are going to see if I is equal to j. In that case, if I is equal to j, it means that you have a duplicate, you will return true. If not, you will return false. Right, now this I is going to iterate through till n, and this j is also going to iterate through n, but it starts from I plus 1. But the time complexity here would be n into n, right? Because for every iteration of I, j goes n times. So this is going to be n square time complexity, it's order of n squared. That is not a very efficient approach, right? This is a basic approach that you might think of, but it's not a very efficient approach, but just know that you can solve it this way as well. The next approach that you could think of is, you can sort this array. Okay, you can sort this array. Sorting this array would give you 1 1 2 and 3. This is the sorted array, right? We have sorted this array. Now this sorted array, you can compare your adjacent elements. Okay, you are going to compare this 1 and 1, and it's obvious that it has a duplicate, so it will return true. If not, you will just move this pair and compare. You will compare 1 and 2, you will compare 2 and 3. You go and keep this, you go and do this all over the array, and you would see if any two adjacent elements are same. In that case, you would return true, saying that it's a duplicate element. We have a duplicate in this array. Now why is this true? Because when you sort the array, all the elements with the same value are going to come adjacent to each other, right? They will be closer, and one will be next to one. It's obvious because it's a sorted array, right? So that is the case here. You can do this approach as well, but the most efficient sorting algorithm that you could think of is going to take you order of n log n. You cannot sort more efficient than that usually. Okay, for a general case. I'm sorry, I think it would have been louder all along. I am sorry about that, I forgot. that the air conditioner was running. Okay, so this would take n log n, right? N log n is quite inefficient as well. You cannot get faster than this using this sorting approach. Now, what else can you do? You can still get more efficient than this. That is how, that is when you use something called a hash set. Okay, a hash set is basically a table. I hope you know this by now, but a hash set is basically a table where you have key and values. Okay, now to search an element in a hash set, it would just take you order of 1 time, just constant time, because we use hashing. Okay, if you don't really know about hashing, just put down the comments. I'll create a separate video for that. But all you have to know is you can use a hash set to solve this, and this is one of the optimal approaches that we are going to use. Now, what you are going to do is you are going to traverse through this array. Now we are at 1. What you're going to do is you're going to insert this 1 into this key, and you're going to set the value as 1. Now this 1 here, meaning that it's a boolean variable. You can make it boolean or anything else, that's fine. But this 1 here, it's just going to denote that this value is present. This value is in fact present. That is just going to denote this value. Okay, this key is the actual value that we have in this array, and this value part of this hash map is going to be, hash set is going to be the boolean variable saying that it's present or not. Okay, now the second variable here is 2, and that is also present. The other one is 3, that is also present. Now the fourth one is 1. Now when you come to this 1, you're going to see if this 1 is already present in this hash set. This 1 is already present here, right? It's at the first position, it's already present here. So what you would do is you would just return saying that it's true that this array has a duplicate. Okay, now in this case, I've already told you that you would require just order of 1 time to check if an element is already present in a hash set or not. So order of 1 to check if it's in hash set, and to iterate through this array to check for every element if it's already present in this hash set. If not, you would be inserting it. That would take an order of n, right? Traversing through this array entirely once. So order of n into order of 1, that is again going to give you order of 1 and some space complexity, because you're going to store this here, right? So order of n into order of 1. So the ultimate time complexity that you would arrive at is order of n. Now this is the approach that we are going to code, and this is the optimal approach that most of the interviews would be expecting. But there is one more neat little trick that you could use, which is basically like, as you know, we are going to implement this in Python, right? There is a method called set, okay, which would basically convert your list into a set. Okay, now what you can do is you can convert this set of, you will pass a list here, and that will give all the distinct elements. Okay, a set is basically a collection of distinct elements. It will remove all the duplicates from that. Now what you could do is, a simple approach is, you can convert this list into a set, and you would find the length of this. Okay, you would find the length of this set, and you will find the length of this list, and you will compare these two. If these are equal, meaning that the length of the list is equal to the length of the set, it means that it doesn't have any duplicates. Okay, because if it had any duplicates, the length of the set would have been reduced, because it only takes distinct elements, right? In this case, the length of the list is 4, because it has 4 elements, but the length of its set would be just 3, because it would only have 1, 2 and 3, because those are only the distinct elements. So the length of the set is 3. Now 3 is not equal to 4, so you would return that it has duplicates. If in case you would have found the length are same, it would mean that it doesn't have any duplicates. So that is basically all the approaches that you could solve this problem with, and we are going to solve this using that hash set approach, right? In Python, we just call it a dictionary, but the underlying data structure is a hash map. Okay, now we can move to Leetcode and try to program this. Okay, like I said, we are going to use a hash map to solve this. So let me just create a hash map, which is basically a dictionary. So I'm just naming it as hash map. Hash map is equal to curly braces will create you a dictionary, right? Now after that, we are going to iterate through this list that we are given. So for num in nums, so this num is going to assume all the values that is present in this nums list. Now what you're going to see is, if you are going to check if your current num, your current value is present in, okay, if that current value num is present in your hash map, it means that you have a duplicate here, right? Your current value is already present in the hash map, meaning that you have a duplicate. If it's not present, then you will come out of this if statement, right? In that case, you are going to add this current element, which is hash map, which is num, right? So you are going to add that current element to your hash map, saying that hash map of num is equal to 1. So in that hash map, in the value of key you will have this num, and in the value of value you will have 1. Okay, hash map of num is equal to 1. You are inserting this element, you are making an entry into the hash map. Okay, we have updated that. Now if it comes out of this loop, okay, meaning no value is a duplicate, okay, in that case you would just return false. I hope this is right. The coding section is very simple for this question. You have just created a hash map, you are iterating through your list, and you're checking if it's already present in the hash map. In that case, it means that it's a duplicate, you're going to return true. If it's not already present in the hash map, you're going to add that to the hash map, and at the end you're going to return false. Okay, let me just run this for the sample test cases. This shouldn't have any problems. Okay, sample test cases have passed. Let me click on submit. Okay, our solution has been accepted, so it's fine. Now this is the hash map approach, right? I have another approach that I told, which is using set. Okay, that is going to be very simple. So you're just going to write an if statement. If len of that list, which is nums, right? If len of that list is equal to set of nums, and you are going to be taking the len of that, len of set of nums. Okay, in that case you would be returning false, so there is no duplicate in that. In the other case, you are going to return true, meaning that there is a duplicate. Now let me just try and run this and see if this works. Yeah, it has accepted sample test cases. Let me just run it for all the test cases. Okay, it is also a solution that is accepted. Now this is just 3 lines of code, right? It's a very simple solution, but the concept basically is that you can use hash map to solve this as well. Okay, so hope you enjoyed this video. See you in the next video, where we'll be solving the next question in the blind 75, and in the description I'll give you a link where you will have Git solution. Like in the Git I have put solution for all these things in C++, Python and Java, so you can go and check that out and give me some suggestions or another question to solve in the description, in the comments. See you in the next video. Bye for now.